Hello students, welcome back. Let's solve the next set of questions of electricity chapter from NCERT class 10 science book. The first question is, why does the cord of an electric heater not glow while the heating element does? Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Third, an electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. Alright, so let's solve the first question. Let's see this picture to solve the first question. So here you can see this is the heating element of the electric heater, while this is the cord or the cable. Now this part of the heater glows while the cable does not heat up, and we can easily touch the cable with our hands even when the current is passing through this wire. Why does it happen so? We'll answer this question using Joule's law of heating. That is, the amount of heat produced in a conductor is given by the formula H is equal to I square RT, where I is the amount of current which is passing, R is the resistance of the conductor, and T is the time for which current is flowing in the conductor. Now, if a certain amount of current passes through this cable and through this electric heater for the same interval of time, we see that this part of the heater glows while the cable or the copper wire does not glow. Why does it happen so? Now the answer to this question lies in its value of resistance. Now the heating element of this electric heater is made up of an alloy, namely nichrome, whereas the wire or the cable is made up of copper, which is a pure element. Now we know that the resistance of the alloys are higher than the pure metals. So the nichrome wire offers a higher resistance to the flow of current than the cable or the wire carrying the current, which is made up of copper, and copper wire has very low resistance. Hence the amount of heat generated is very less in case of copper than in the case of this alloy. The heating element of the coil of an electric heater is made up of nichrome glows because it becomes red hot due to the large amount of heat which is produced on passing current through it because of its high resistance. But the cord or the connecting cable of the electric heater is made up of copper. It does not glow because negligible heat is produced in it by the passing current, because copper has an extremely low resistance. Hence, the heating element glows while the copper wire or the cord of the electric heater does not glow. Now, to summarize this answer, we can write the heating element of an electric heater is made up of alloys like nichrome. Alloys have a higher resistance. So, when electric current passes through the alloy, it blocks the current, and thus the electric energy gets converted in the form of heat and light. Hence, it glows. But the cords are made up of copper, which have extremely low resistance and lets the current pass through them easily. Hence, it does not glow. So, this is the answer to this question. Let's solve the next question. The next question is, compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. So, let's write down what all are given. The charge Q is given as 96,000 coulomb and the potential difference is given as 50 volt. Time is given as 1 hour. Now we have to ask the amount of heat which is generated. So there are two ways of solving this question. Let me teach you the easier way. Now we know that the potential difference V is given by work done by charge, that is V is equal to W by Q. So this implies W will be V into Q. Work done is equal to the potential difference multiplied by the amount of charge. Now we know that energy is the capacity of a body to do work. So energy and work have the same units. So here we can write here that energy is equal to V into Q. So energy here refers to the heat energy. So we can write here H is equal to V into Q. So V is given here as 50 volt and the charge is given here as 96,000 coulomb. So the answer is 48 lakh joule, which is equal to 4.8 into 10 to the power 6 joule. So the answer to this question is H is equal to 4.8 into 10 to the power 6 joule. Let's go over to the next question. The next question is, an electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So let's write down what all values are given. The resistance is given as 20 ohm. The amount of current I is given as 5 ampere and the time here given is 30 seconds. So the heat which will be generated will be given in accordance with Joule's law of heating, that H is equal to I square RT. Substituting the values of I, R and T, we get I is 5 ampere, so it is 5 square into resistance is 20 ohm and time is 30 seconds. So it is 25 into 600, which is 15,000 joule, or we can write it as 1.5 into 10 to the power 4 joule. So the amount of heat which is developed in 30 seconds is 1.5 into 10 to the power 4 joule. So this is the answer to this question. So now I hope you have understood the solution to these questions. If this video was helpful to you, please like this video, share it with your friends and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.